Our 3D illusion. What if the world around you, the very space you occupy, is a profound and elaborate deception? Not a malicious lie, but a fundamental limitation. The chair you're sitting on, the screen you're looking at, the air you're breathing, it all exists within a framework so familiar, so intuitive, that we never think to question it. Length, width, and depth. Three simple axes that define the entirety of our perceived reality. From the microscopic dance of atoms to the majestic waltz of galaxies, everything we have ever known, measured, or experienced is painted on this three-dimensional canvas. We take it for granted as the ultimate truth of existence. But what if it isn't? What if this deeply ingrained perception is merely a biological filter, a trick of our senses, rather than a cosmic law? This is the provocative, mind-bending idea at the very heart of modern physics, that our reality, as we experience it, might be an illusion. A broken, fractured, or at the very least, a radically incomplete picture of a much grander, multidimensional cosmos. To grasp how our most fundamental truths can be overturned, we only need to look at our own history. For millennia, humanity lived on a world that was, for all intents and purposes, flat. All sensory evidence pointed to a flat Earth. The ground beneath your feet was flat. The horizon was a straight line. If you walked for a day, the world didn't curve away from you. This was the data. This was the reality. To suggest otherwise was to sound like a madman. The idea of a spherical Earth was counterintuitive, an abstraction that defied everyday experience. Yet the truth was hiding in plain sight, in the subtle clues our senses couldn't immediately piece together. The way ships disappeared hull first over the horizon. The curved shadow the Earth cast upon the moon during an eclipse. The truth wasn't that the world was a lie, but that our perspective was limited. We were creatures living on the surface of a 3D object, perceiving it as a 2D plane. The third dimension, the vast curvature of the planet, was too large in scale for our biology to process directly. Now, take that same logic and elevate it. What if we are in the exact same situation today? What if we are creatures living within a 4D, 5D, or even 11-dimensional universe, but we are biologically and perceptually locked in to seeing only 3 of them? The classic thought experiment to explore this is Edwin Abbott's Flatland. Imagine a universe that is a perfect 2-dimensional plane. Its inhabitants are geometric shapes, triangles, squares, circles. They have length and width, but no concept of height or depth. Their entire existence, their physics, their reality, is confined to this plane. Now, imagine a 3-dimensional being, a sphere, decides to visit Flatland. How would the Flatlanders perceive this? The sphere wouldn't just appear. As it passed through their 2D plane, it would first manifest as a tiny point. As more of the sphere intersected their reality, this point would grow into a circle, expanding to a maximum diameter before shrinking back down to a point and then vanishing completely. To the square, the protagonist of Flatland, this would be an act of impossible magic. An object appearing from nowhere, changing its size and shape, and then disappearing into nothing. It would violate every known law of Flatland physics. The square couldn't see the sphere in its true 3D glory. It could only perceive the 2D slice of the sphere that was currently passing through its plane of existence. The sphere could even look inside the square, seeing its internal makeup, something no 2D being could ever do. It would be like a god. The sphere isn't magical, of course. It's simply operating on a dimensional axis that the square is completely blind to. Now, turn the mirror on ourselves. We are the flatlanders. Our three-dimensional universe is our flatland. If a four-dimensional object, a hypercube or a tesseract, were to pass through our reality, what would we see? We wouldn't see the full 4D object. We would only perceive the 3D slice of it that was currently intersecting our space. It might appear as a sphere that suddenly materializes in the middle of a room, expands, contorts into bizarre non-Euclidean shapes, and then shrinks and vanishes. To us, it would be a miracle, a ghost, a violation of the conservation of mass. But in the higher dimensional reality, it would be as simple as your finger passing through a sheet of paper. This is the core of the problem. Our perception of reality, our common sense, is built entirely upon the rules of the three dimensions we can see. But if there are more, then the true rulebook of the cosmos is far stranger, and our understanding is fundamentally broken. It's like trying to understand a feature film by looking at a single static photograph. You see a part of the story, but you're missing the crucial dimensional of time that gives it meaning and context. We may be looking at a single frame of a much larger, dimensionally complex movie. So if our senses are indeed the gatekeepers, filtering out the vast majority of existence, what does science say is really out there, hiding just beyond the veil?
Beyond our senses. The answer to what lies beyond our limited perception isn't found in philosophy or speculation, but in the most rigorous and demanding field of human thought, theoretical physics. For decades, physicists have been wrestling with a colossal problem. We have two incredibly successful theories that describe our universe. General relativity, Einstein's masterpiece, beautifully describes the universe on a grand scale. Planets, stars, galaxies, and the force of gravity that orchestrates their cosmic ballet. Then we have the standard model of particle physics, which uses quantum mechanics to describe the universe on the smallest possible scale. The bizarre, probabilistic world of subatomic particles and the forces that govern them. Both theories work perfectly within their own domains. But when you try to make them work together, like in the heart of a black hole or at the moment of the Big Bang, they break down. The math produces nonsensical infinities. It's the biggest clue that we're missing a crucial piece of the puzzle. This is where the idea of extra dimensions goes from a fun thought experiment to a scientific necessity. The leading contender for a unified theory is string theory. It proposes a radical reimagining of reality's fundamental building blocks. For a century, we've thought of particles like electrons and photons as infinitesimal points. String theory suggests this is wrong. At a level of reality far smaller than anything we can currently probe, these particles are actually tiny, one-dimensional vibrating loops of energy, or strings. The universe is, in this view, a cosmic symphony. Just as a violin string can be plucked to create different musical notes, the different ways these fundamental strings vibrate give rise to all the different particles and forces we see in the universe. One vibration pattern appears to us as an electron, another a photon, another a quark. It's an incredibly elegant and powerful idea. But here is the catch, the part that shatters our 3D worldview. The mathematics of string theory is incredibly precise and demanding, and it delivers an unambiguous verdict. It simply does not work in a universe with only 3 spatial dimensions. For the equations to be mathematically consistent, for them to cancel out the dangerous infinities and actually produce a universe that looks like ours, they require that space-time has more dimensions. The most promising versions of the theory require a staggering 10 or even 11 dimensions in total. Our familiar 3 spatial dimensions, 1 dimension of time, and 6 or 7 additional spatial dimensions completely hidden from our view. So, where are they? If they exist, why can't we see them or move through them? The prevailing idea is a concept called compactification. Imagine a tightrope walker high above a circus. From the audience's perspective, the tightrope is a one-dimensional line. The walker can only move forward or backward. But for a tiny ant standing on that same rope, reality is very different. The ant can move forward and backward along the rope's length, but it can also walk around the rope's tiny circular circumference. The ant experiences an extra dimension that is simply too small for the circus audience to see. The extra dimensions of string theory are thought to be like this. They are compactified or curled up on themselves at an unimaginably small scale, the so-called Planck length, trillions of times smaller than an atom. At every single point in our familiar 3D space, there exists a tiny, complex 6-dimensional shape, a Calabi-Yau manifold, a geometric space so small we can never experience it directly. This idea was further refined into what is now called M-theory, which unified 5 competing versions of string theory and proposed an 11-dimensional reality. M-theory introduced an even wilder concept, branes. Short for membranes, branes are surfaces that can exist in any number of dimensions. And this leads to the most mind-bending proposal of all, Brane Cosmology. This model suggests that our entire known universe is just a 3-dimensional brane floating within a much larger, higher-dimensional space called the bulk. We and all the matter and energy we know are stuck to this brane, like water droplets on the surface of a bubble, unable to perceive the vast empty space outside. This isn't just a wild story. It offers a stunningly elegant explanation for one of physics' most stubborn mysteries. Why is gravity so much weaker than the other fundamental forces? Electromagnetism is vastly more powerful than gravity. A simple fridge magnet can defeat the gravitational pull of the entire Earth. In Brane cosmology, the forces of the standard model are like open strings, with their ends stuck firmly to our 3D brane. But gravity, the theory suggests, is created by closed loops of strings. These closed loops are not tethered to our brane and are free to leak out into the higher dimensional bulk. Gravity, therefore, feels so weak to us because its influence is being diluted across all the extra hidden dimensions. It's the one force that can see the full multidimensional reality. The search for these dimensions, for evidence of gravity leaking away, is now at the forefront of experimental physics at places like the Large Hadron Collider. We are no longer just flatlanders guessing about a third dimension. We are actively searching for the shadows it casts on our world. Our reality isn't broken, perhaps, but it is profoundly incomplete. We are just beginning to read the first page of a cosmic story whose true number of chapters we can't yet even imagine.